Hi, and welcome to the Chem Safety webinar on controlling human vibration hazards in the workplace. Please note that if you're watching our webinar live, there's a Q&A at the end, at the bottom of the screen, where you can post any questions and I will answer at the end. And also our details will be in the follow-up email, which will also include a link to the recording of today's session and some online resources. So just an introduction, I'm Christine de Klerk. I'm an occupational hygienist. I work for Chem Safety. I've been in the industry for at least 13 years now. I've worked in various industries, including mining, petrochemical, chemical, manufacturing, logistics, and so on. And I've done heaps of assessments in noise and hazardous chemical substances, and also vibration. So let us go on. So what is human vibration? So human vibration is, vibration explained is, vibration is a mechanical phenomena whereby oscillations occur about the equilibrium point. So basically in simple terms, vibration means quickly moving back and forth or up and down about a fixed point. The vibration may be periodic or have a pattern, or it may be random. It is something that is vibrating will shake, and as you can see, the vibrating object emits waves, and these waves will move the energy through a medium, which is usually the human body. So human vibration is the effect of mechanical vibration of the environment on the human body. And you have various sources of vibration, for example, vehicles or power tools, like you're operating an angle grinder or you're driving in a forklift. And so many people are exposed to vibrations during their working day. So there's two types of human vibration. We have hand-on vibration. So it is when vibration is transmitted to the hand, and whole body vibration. It is when vibration is transmitted to the entire body by the surface that is supporting it. And this is usually when you're driving trucks or forklifts, or any vibration that is emitted through the seat or the feet. So diving into hand-on vibration. So hand-on vibration has a problem that it can cause various effects, and this is collectively known as hand-on vibration syndrome. So with regular exposure to excessive hand-on vibration, you may have long-term effects. And the term hand-on vibration syndrome is used to refer to any complex disorders, whether it be musculoskeletal or nervous system, or if you have loss or weakness in the hands. So vascular disorders, that includes whitening or blanching of the fingers, and is usually triggered by cold exposure. So we have various terms that are used to describe this phenomena, and it is known as dead or white finger, Raynaud's phenomena that is caused by occupation, or vibration-induced white finger. So blanching is influenced by several factors. So the characteristics of vibration exposure will have an influence on it. Also the duration of exposure, the type or the tool of work process, environmental conditions such as temperature, airflow, or humidity. Because temperature, once again, it causes constriction of the vessels in the fingertips. So this aggravates the whole problem with blanching. And then some biodynamic or ergonomic factors such as grip force, push force, and arm position, because the more strain you place on your wrist or holding something awkwardly, it can also cause constriction to your vessels and also contribute to that. And then individual characteristics is just how susceptible you are to these influences. So with neurological disorders, is referred to tingling and numbness in the fingers and the hands. And the symptoms tend to worsen when the hand-on vibration continues. So Workers exposed to hand-on vibration may experience tingling and numbness in their fingers. That has been reported. And then vibration exposed workers may exhibit a reduction in the normal sense of touch and temperature, as well as impairment of manual dexterity. So basically what it means is they'll have trouble picking things up, especially small little things, like when you're working in a workshop and you want to pick little screws up or any of your tools that you want to use. So carpal-tunnel syndrome is usually an ergonomical factor, but it can be caused by hand-on vibration as well, because of the way that you might hold the tool that you're operating, especially if you've got a angle grinder and you want to do something and you're doing it in a awkward manner to reach a weird corner. So musculoskeletal disorders. So with prolonged exposure to hand-on vibration, people have been complaining of muscular weakness, pain in their hand and arms, and diminished muscle strength. These disorders may also be related to ergonomic stress factors arising from heavy manual work. And then furthermore, excess occurrence of wrist and elbow osteoarthritis, as well as hardening of the soft tissue at the size of the tendon attachment, mostly in the elbow, have been found in miners, road construction workers, and metalworking operators of percussive tools. It is just because they're using angle grinders a lot, and at the angle that you're holding it, it does not only affect the wrist, but it also affects the inner elbow and the other elbow and the shoulders. And then also it can lead to inflammation of the tendons, which is called tendonitis, and the sheaths in the upper limbs. And then Dupuytren's contracture is a disease of the vascular tissue of the palm of the hand. It is when there's so much damage occurring or strain on the inside of the palm that the tendons start to harden or contract, which causes many people not able to open their hands fully. It's also known as the claw syndrome. Okay, so assessing hand-on vibration. So you'll typically do a risk assessment, and during the risk assessment, you will identify where there may be a risk from hand-on vibration, the estimate of the worker's exposure, and compare them with the exposure action value and exposure limit value. Identify available risk controls, identify the steps you plan to take control, and you have to record the assessment. It is just easy to have a paper trail, see what you have to do and what you have done. And then questions that you can ask to decide whether you need further action is, what type of tools are being used? Do you use rotary action tools like grinders or polishers, or do you use impact or percussive tools like impact hammers or pneumatic impact wrenches? So with impact or percussive tools, the levels of vibration are likely to be much higher than rotary tools, and some hammer action tools can exceed the exposure action value within a few minutes. So it is important to note what type of tools you have at your facility. So when determining the vibration magnitude, there's a nifty calculation that is done where we take into consideration the three axes, which is the x-axis, the y-axis, and the z-axis. And the x-axis is usually in the up and down position. The y-axis is in the side-to-side position, and the z-axis is in the forward and backwards position. And then the total frequency weighted acceleration of those three axes are calculated, and this has to be done at the point where the vibration enters the hand. So if you're holding the tool, you will typically measure it as close to the tool as possible and not at a different position on your arm or your shoulder or your elbow. So when you want to determine what the vibration magnitude is of any tool, you can typically use the manufacturer's emission data. A lot of manufacturers do provide it in the little booklet with the tool. And then there's other sources as well, such as this one is from the EU Good Practice Guide on Hand-on Vibration, where they've done heaps of studies on different hand tools or power tools, and they've even calculated what's the average acceleration when the tools are well maintained. So that's in your 25th percentile, the average of any tool, which is the 75th percentile, and then the maximum it is when the tool needs some maintenance or is being used incorrectly, or whatever the case may be. But sometimes, or in most cases, it is hard to find adequate information on the equipment that you use, and also you want to determine what your work is, or the person using the specific tool in the specific condition, what they are exposed to. So in this case, measuring hand-on vibration directly is a good approach, was the best approach. And measurements are done in accordance to the international ISO standard 5349. So with the exposure limits, there are no exposure limits currently in New Zealand, but WorkSafe proposes the exposure limits that are based on the vibration directive limits, which is a daily exposure action level of 2.5 meters per second squared, daily exposure limit value of 5 meters per second squared. And even though these are the set limits or the set values, there have been instances where people start to develop hand-on vibration injuries at very low levels as well. So when reducing or controlling the hand-on vibration risk, you'll typically follow the hierarchy of control, which is eliminating the risk, substituting the risk, isolating the risk, engineering controls, administrative controls, and PPE, which is the very, very last form and the least effective form of protection. So with substitution, what is meant with that is substitution or other working methods. It may be possible to find alternative work methods to eliminate or reduce exposure to vibration. This may involve mechanization or automation of the task, or substitution of alternative work processes, trying different tools, like more modern tools is usually a good approach. And then doing some research on what type of tools are on the market these days. And that can be done through the trade associations, other industry contacts, equipment suppliers, or trade journals. So when you're selecting equipment, it is important that you make sure that the equipment selected is allocated for the task is suitable and can do the work efficiently. Because if the equipment is unsuitable, you might have to do the task longer than expected, and thus you are exposed to the vibration longer than is necessary. So it is very, very important that you also carefully select other consumables related to your tools, such as abrasives for the grinders and tool accessories such as drill bits. And then also just having a look at the design of the equipment itself, where the handles are placed, whether you can hold the equipment more stable, more comfortable without placing any unnecessary strain on your wrists or elbows. So with that, you've got a purchasing policy, and with your purchasing policy, the department makes sure that any equipment that is purchased, you take into consideration both the vibration emission and your operating requirements. So power tool manufacturers and importers, suppliers, or tool hire firms should be able to help you to select the most suitable and safest tools for your particular needs. So, and also when you're selecting tools, you should also consider economic factors such as tool height, handle design and comfort, grip forces, and ease of use and handling. Also, workstation design helps to reduce vibration risk. So what is meant with that is using jigs or anti-vibration handles, such as the photo in the slide. That is a jig that is used to keep whatever is being drilled in place. So there's no unnecessary force placed through the wrist, and thus reducing the exposure risk. And then also using resilient materials, reducing grip and push forces. So like I said, supporting heavy work pieces. And you can also use tension trains, also called balancers and manipulators. And then changes in the texture and material of grip forces may also allow the operator to use smaller grip force to hold and control the tool. So a great way also to reduce vibration risk is training in information. So the best is to explain to the operator the potential injury arising from the work equipment use, so that if they understand what they are doing and how they can potentially cause harm to themselves, they might be more wary to use the tool more appropriately or in a more secure position. And then also just explaining what's the exposure limit values and the exposure action values and what's the significance behind them. And then also, if you're doing a vibration risk assessment or any vibration measurements, just to relay the results to them and what control measures are being used to eliminate the risk from hand-on vibration. So also, it is very helpful for any operator to know what they should do when they detect a problem with their hand tool, and should they report it to someone, and what department do they report it to. So all these little things can add up to having a system in place to rid of any faulty equipment or equipment that are emitting more vibration than they should. So another way is a administrative way, and that's work schedules. So it's limiting the time that workers are exposed to vibration from some tools or processes. So you can do some task patterns or task rotation, where the person will do angle grinding for, say, half an hour a day, and then they might go on with some other tasks during the day and then come back to further angle grinding, say later in the afternoon, just to reduce the exposure risk and allow the affected areas to take a rest a bit. And then also, it's important to plan the work ahead to avoid workers being exposed to vibration for long continuous periods. So say, for instance, you have to grind a large frame. So knowing what you are going to do today, having a plan in place reduces the risk in the sense of they're going to grind for 30 minutes, they're going to finish that section of the job, and it is done, instead of going to the frame, grinding a bit, coming back, it doesn't fit, then they have to go do it again. And that in the long term increases the vibration risk. And then also, when you're implementing new work patterns with work rest regimes, it's important for the supervisors also to take note whether workers are falling back on old patterns, or are they actually keeping to the newer patterns, just to ensure that they have enough breaks. And then the least form of protection is vibration gloves. They do not always provide sufficient protection against vibration, especially at frequencies below 150 hertz. So, and also, if some of the gloves are not properly fitted, they may cause a bit more wonkiness when holding the tool, and that results in holding the tool incorrectly or other health and safety risks, and ultimately increase the risk of hand-on vibration. So that is why it is important to rather implement engineering controls or administrative controls rather than opting for vibration gloves. Also, be wary of low body temperatures. Like discussed previously, that the colder your hands are, the more likely it will lead to hand-on vibration syndrome with the blanching of the fingertips. So low body temperature increases the risk of finger blanching. So you can avoid outdoor work. You can avoid working outdoors when it's cold weather. And then when you're working indoor, just make sure to be wary of any factors that can lead to cooler air or cold hands, such as the pneumatic tool that you're operating may emit some air that is cooling, or you might be operating a tool that doesn't have a grip, so you're directly in contact with a cold surface. And then important to, if you have to operate these tools in cold environments, just to have additional gloves which are appropriately fitted to avoid any other unnecessary health and safety risks, and just wearing them under your handling gloves can also help to reduce any effects from cold. Also very important is to make sure your tools are regularly serviced. A tool that is not operating as it should will become a bit wobbly or wonky, and that can lead to unnecessary vibration being emitted. So it's always a good thing to also dress grinding wheels correctly, or lubricate any moving parts, or replace any worn parts. So make sure there's a maintenance program in place where you check your tools and check the consumables to see that everything is operating as it should. And then doing regular monitoring and reassessment to make sure that the controls that you have implemented are doing what it should. And then if there's any additional controls needed, you can implement it. Or it is also good to revise the whole system when you do implement new tools or work patterns or new controls. So with whole body vibration, it's a bit different in the sense of whole body vibration causes motions and forces within the human body that may cause discomfort. So is everything related to the entire body posture and not just fixed to the wrists? So it has a bit of a more overall effect on the human body. So other effects that it may have is, apart from low back pain and muscle fatigue and shoulder pain and anything related to the spine, is you can get headaches or nausea, vision problems, can lead to fatigue, even reproductive issues in females, and it can have some gastrointestinal discomforts. So the effects on the back, neck, and shoulders. So there's a higher prevalence of rate of low back pain and herniated disc and early degeneration of the spine, especially with people who operate mobile equipment for the entire shift versus those who just do it infrequently. A good scenario is a person who's working in a warehouse where they operate a diesel forklift and they operate this, say, 8 to 10 hours a day, versus someone who works in a workshop and they have to bring in a tool and they will operate the forklift, say, for a maximum of 10 minutes a day. So looking at that dose, the person at the warehouse might have a higher prevalence for back injuries than the other person. So as mentioned just now, driving of mobile machines. So factors that also add strain on the back is prolonged sitting in constrained postures. So it's basically, if you're operating mobile equipment that has limited space and you have to be in a small position for a long time, it is a good approach just to take a break every now and then and stretch. And then also frequent twisting of the spine. That is typically if you're operating a forklift that doesn't have a rear view mirror and you have to look behind you the entire time. The repetitive action can lead to a repetitive strain injury. And then any unexpected movements. So always be wary on the ergonomical factors also behind whole body vibration. So with saying that your movements should be controlled when operating mobile equipment. So assessing whole body vibration exposure. So once again, as with hand-on vibration, you'll do a risk assessment to identify where's the potential sources of whole body vibration. What is the scenario? Just like I explained, the forklift driver in the warehouse versus a forklift driver in a workshop. And then identify the available risk controls. So is there anything on the market, or is there any way of reducing the risk while you're operating a forklift? So just doing a bit of research on what is available out there. And then also be very aware of ergonomic factors that may contribute to the back pain or to the whole body vibration effect. And then once again, also it's always a great idea to record the assessment so that you can revise your steps frequently. So when we're determining vibration magnitude, like I mentioned, it's a different sort of exposure. So the three axes are taken into consideration whether you're standing, so whether vibration is coming through your feet or in a sitting position. So once again, you've got your x-axis, that is usually your forwards and backwards motion, your y-axis that is side to side, and your z-axis that is up and down. What is also really nice about whole body vibrations is you can determine the pattern of how the person is operating the mobile equipment. So say, for instance, your dominating axis is the z-axis. It already tells you that the driving surfaces might be a bit uneven. So the person is bouncing up and down constantly on the seat. Whereas with the y-axis is also uneven driving surfaces, or going around corners very, very abruptly. And then the x-axis is stopping and accelerating very quickly and not doing it in a controlled fashion. So So data that is available, once again, is just talking with the manufacturers regarding whole body vibration on their equipment. And then if they don't have it available, the EU Good Practice Guide for Whole Body Vibration, they've also done heaps of research on mobile equipment. So there's also a 25th percentile, 75% percentile to indicate what's the average of acceleration versus when using the mobile equipment in a good condition or using the mobile equipment in a condition which requires maintenance or speeding or just not using it correctly. So in many cases, you would want to know what's the vibration of a specific mobile equipment at your premises. So it is a great idea then to measure the vibration directly so that you can identify which forklift or which truck is causing more vibration to your workers than, say, other mobile equipment. And this will be done according to the ISO standard 2631. So when evaluating whole body vibration, it's a bit more intricate than hand-on vibration. in the sense that you take into consideration the crest factor. So the crest factor is the ratio of the peak value of a waveform, and it's basically the peak to the RMS ratio. It's a pure number. So what is meant with that is when you're looking at a vibration pattern, you will see different waves. So waves with higher peaks will have a higher crest factor, whereas waves with smaller peaks will have a lower crest factor. So when your crest factor is less than 9, you'll use the action value of 0.5 meters squared for your daily exposure limit, or you'll use a, that's your action value, or you'll use the exposure limit of 1.15 meter per second squared. And that's usually your RMS. You'll use your RMS for that, and it's your root mean square. And then when your crest factor is more than 9, you'll use your VDV, and your VDV will be used to see if your daily exposure action value is 9.0 meter per second squared. And then also your total whole body vibration limit of 21. Sorry, I'm just quickly checking one of my notes. So what is meant with the VDV is the vibration dose value. So with the vibration meter, to access the crest factor, the VDV, and the RMS, they do have different settings afterwards when evaluating your data. So when you see that your crest factor is higher than 9, then you'll use your set of data, which is your RMS data, or if it's less than 9, and then if your crest factor is more than 9, you'll use your VDV set of data. So when you identify that some of your mobile equipment is emitting more vibration than it should, then you can control the exposure. So once again, the hierarchy of control as discussed in hand-on vibration. So the easiest is to substitute. It's just taking little things into consideration. So say for instance, you have a little plant where you're grinding, say, iron ore, and it's just a little plant. Instead of taking the product to and forth with a forklift, you can just hook up a small conveyor belt that reduces the risk of whole body vibration. And then you can keep up to date with any methods available in the industry. So once again, talking with your trade association, other industry contacts, and just doing some research on equipment suppliers and reading through trade journals. So for the equipment selection, it is important to make sure that the equipment is suited for the task that you want to do. So make sure that workers do not take longer to complete the task than is necessary. So what is meant with that is if you can, say for instance, want to take a 1-ton bag to a different section, you'll use a suitable forklift for that instead of moving it to another mobile equipment and then trying to move it with other mobile equipment to the point where you need it to be. And then also very important with equipment selection is taking into consideration the cab layout, whether the controls are high or whether they are hard to access, so you have to do frequent twisting of the back, or you have to lift your elbows and your shoulders at uncomfortable positions. And then also the selection of the tires are very important. So as a rule, the harder the tires, the more vibration you'll have, or likewise with the shocks. If you don't have sufficient shocks on your mobile equipment, you'll have higher vibration going through the seat. So with your purchasing policy, it's just taking into consideration the types of mobile equipment that is available, talking with suppliers whether they have new equipment or new technology on the market, or other things like improvements on tire quality or shocks, or even seating, whether there's new designs for workers to sit in more appropriate postures while operating mobile equipment. And then your task and process design. So you want to keep your whole body vibration exposures to as low as practical. So what is meant with that is to take regular breaks. So if you're operating, say, a bobcat at a construction site, to make sure that if there are breaks available, to take those breaks. And then during those breaks, it is recommended that you do daily stretches, just to make sure that you are not confined to a enclosed position, and that places more strain on your shoulders and upper back and neck and so on. And then rough and uneven surfaces can also contribute to high body vibration. So when you have a yard where you're operating mobile equipment and it's hard to keep the road surfaces smooth, say for instance inside a quarry or a pit, it is just to take that into consideration while operating the equipment, to maybe operate the equipment at a slower pace than normally, or being more wary of, you know, turning or accelerating a bit more controlled. And then do try to keep the road surfaces in a good condition by filling potholes or trying to remove large objects from the driving surfaces. That will also reduce the risk of whole body vibration. And then also providing a suitable suspended seat, which is set correctly for the driver's weight. So in many instances, if the person is sitting on a smaller seat, then that is suited for his body posture or for his body, they might sit unevenly or uncomfortably, and then that can result in further strain on the back. Okay, and then you want to maintain a good body posture. So improving the driver's vision from the cab to minimize the twisting of the back and neck. So providing forklifts with rear view mirrors, that can help a lot, or even convex mirrors throughout the warehouse can also help to reduce the risk of, you know, repetitive motions to see where you're going. And then providing a seat that fits all the drivers that will use the vehicle. Instead of providing one little seat, try to opt for a universal seat with good vibration absorption. And then the use of seat belts is very important, as it can maintain the driver in the best position to provide support for the back. And then training information is important to inform workers of how they are potentially exposed to whole body vibration, what the effects are if you're not operating the mobile equipment appropriately, if you're speeding, not adhering to the speed limits, or if you're turning around corners too quickly, or just twisting your back too much. So just to utilize the rear view mirrors that you have on the mobile equipment. And then reducing exposure time. So work schedules, task rotation, and regular breaks. So once again, when you're on your regular breaks, just do some stretches. Task rotation is to operate the forklift a bit and then continue with some admin work or some stock picking activities, and then to continue with mobile equipment jobs. And then maintenance. So you want to maintain the driving surfaces. You want to maintain your mobile equipment, because the more damage to, say, the shocks or the wheels, the more likelihood that vibration might increase. So regular checks of your mobile equipment, regular servicing, regular maintenance, that will help reduce the risk of that. And then you want to lubricate the seat or other suspension systems to ensure that it is working as it should. And then suspension seats, there's quite a lot on the market. It is very important to, when you're opting for a good suspension seat, not to go for the cheapest option, because many times a poor choice of seat suspension can result in a higher vibration exposure. So if it's not sturdy enough or it's of poor quality, it might cause more vibration and then just exaggerate the whole problem. Okay, so any questions? So I see there are a few questions, the Q&A. I'll answer them. Guys, so the first question, are shuttle van drivers who work 8 hours a day at risk of whole body vibration? Yes, they are. So I will recommend that you do a risk assessment and a vibration assessment. So they can be exposed to whole body vibration, especially if it's for such a long duration. So thank you everyone for attending this webinar. And like I mentioned, we'll send an email with a link to our YouTube page. And that's me. Thank you.